Hello everyone, welcome back to my channel. So in this video we will learn about electric field intensity. Electric field intensity, or it is also called electric field strength. Electric field strength, and generally it is represented by E bar. Okay, so it is represented by E bar, right? If you are first time to my channel, please consider subscribing and press the bell icon to get the notifications from my channel. Right, so what is electric field intensity? So the electric field intensity, is the force. It is the force that a unit positive charge experiences. The force that a unit positive charge experiences when placed in an electric field. So electric field intensity is the force that a unit positive charge experiences when placed in an electric field. Okay, so mathematically it is given by electric field intensity is equal to, so force on an unit positive charge, so force by charge. Okay, so force by charge, so force that is that a unit positive charge experiences in an electric field. So this is electrostatic fields we are talking about, and force per unit charge is going to be electric field intensity or electric field strength. Okay, so what are the units for this electric field strength? What are the units for this is volt per meter. Volt per meter, because we will see that it is the ratio of electric potential to distance between the charges, so that we'll see later, but the units are, you have to remember the units, so units are volt per meter. Okay, or force Newton. Okay, so unit for force is Newton and unit for charge is Coulomb, so it can also be Newton per Coulomb. Newton per Coulomb also represents the electric field intensity only, or standard unit which we use for electrostatics is volt per meter. Okay, so from Coulomb's law we know that the force exerted, so if there is a point charge, 2 point charges or two charges q1 and q2 whose distance is r from origin and r dash from the origin, so the distance here is r minus r dash. So the force exerted by q1 on q2, so this is the direction of F12, and reversely, so this is the direction of F21. Okay, so this is what we have learned in Coulomb's law, right? So the force is given by q1 q2 by 4 pi epsilon naught r square into ar cap newtons. Okay, so this is the force exerted by this Coulomb's law, and electric field intensity is again derived from Coulomb's law only, because it is the ratio of force by unit charge. So if you take q2 as q, okay, so if you take q2 as q, then what is the force by q, that is force by q2. So send this q2 to this left hand side, so this force by q is called as electric field intensity, is given by q1 by 4 pi epsilon naught r square into ar cap, or generally q1, instead of q1 I am taking q. Okay, let it be any charge. So f bar by q is equal to q by 4 pi epsilon naught r square into ar cap. So this is the formula for electric field intensity. Okay, so electric field intensity is again derived from Coulomb's law only. Okay, the formula for this is again derived from Coulomb's law only. And what is r? R is equal to r minus r dash. So this is the distance between the 2 point charges. So r is equal to r minus r dash. Therefore, then what will be this E bar? E bar is equal to q by 4 pi epsilon naught. So r is r minus mod r, that is r. So this is r bar, okay, the vector in the direction of force. So r bar is equal to r, that is modulus of this r is equal to modulus of r minus r bar. Okay, so this will be r minus r bar whole square, because there is r square here, so this becomes r minus r dash whole square. And there is the unit vector in the direction of r. So unit vector in the direction of r is given by r minus r dash by modulus of r minus r dash. Okay, so unit vector in the direction of r is given by this. So final expression for this is q by 4 pi epsilon naught r minus r dash whole cube. This is r minus r dash whole square. This is again one more r minus r dash. So it becomes r minus r dash whole cube into r minus r dash. So this is volt per meter. So this is the formula for calculating the electric field intensity. Okay, so this is again obtained from Coulomb's law only, right? Extension of the Coulomb's law, that is extension of the force concept. So once you understand the force, electric force present between the two charges, we can write similarly the electric field intensity or electric field strength present between those two charges when placed in the electric field. Okay, so electric field intensity, it also obeys superposition principle. Okay, so we have seen this superposition principle in case of force also while we are learning about Coulomb's law. That is, if there is a point, so if this is the origin O, and if there is a charge q at a distance of r, and there are n point charges q1, q2, q3 and so on up to qn. So there are n point charges which are at a distances of r1, r2, r3 and so on up to rn. Okay, so we have seen that the force exerted by q1 on q and force exerted by q2 on q, q3 on q and so on up to qn on q, or sum of the forces. So the total force is equal to the sum of the individual forces. Similarly here also electric field intensity, so electric field intensity due to q1, q2, q3 so on up to qn at distances r1, r2 so on up to rn on q, on the charge q is given by so electric field intensity is given by E1 plus E2, that is E1 bar plus E2 bar plus E3 bar plus so on up to En bar. Okay, so this is called as superposition principle. Okay, so the total electric field intensity is equal to the sum of electric field intensities. So what is E1? E1 is the electric field intensity due to Q1 on Q. Okay, so the distance between Q1 and Q is given by R minus R1. So distance is given by, this distance is given by R minus R1. Similarly, the distance between R and R2, this distance is given by R minus R2. Similarly, the distance between R and R3 is given by R minus R3. Similarly, the distance is here R minus Rn. Okay, so these are R1 bar, R2 bar, this is R3 bar, and so on up to Rn bar, right? So if you substitute here, what you will get, Q1 into the distance R minus R dash. So just now we have seen the formula. So what is the formula for electric field intensity? Q into R minus R dash by 4 pi epsilon naught into mod R minus R dash whole cube. Okay, this is due to single charge. Now we have n point charges like this. Okay, so first is due to Q1. So Q1 into R minus R dash, or if you take it as R1, okay, instead of R dash we'll take it as R1, because the distance is, we have considered is at the Q1 is at a distance of R1 from origin, so it is R minus R1 into 4 pi epsilon naught modulus of R minus R1 whole cube plus Q into R minus R2 divided by 4 pi epsilon naught into R minus R2 whole cube plus Q into R minus R3 divided by 4 pi epsilon naught into modulus of R minus R3 whole cube plus so on, plus this is Q2, this is Q3, so on up to Qn into R minus Rn divided by 4 pi epsilon naught into modulus of R minus Rn whole cube. Okay, so if you write in a form of summation I is equal to 1 to n, summation I is equal to 1 to n, so you can write 1 by 4 pi epsilon naught as a constant. We can write out of summation 1 by 4 pi epsilon naught, this is E bar, 1 by 4 pi epsilon naught summation I is equal to 1 to n Qi into R minus Ri divided by modulus of R minus Ri whole cube. Okay, so this is the formula for electric field intensity due to n point charges. Electric field intensity due to n point charges. Okay, so due to n point charges, so they may give you in problems to solve in board exams or in gate exam, they may give you 2 or 3 charges and they may ask you to find the electric field intensity. Okay, so in my next video we'll solve one problem on this, then you'll understand clearly the concept of electric field intensity. Okay.